Okay, so for those of you who are not able to be in class on Thursday, the 25th, I'm going to go ahead and make this video for you so that you can pretty much pretend like you were just here with us as we were going through these sources of light. Now, unfortunately, we're not going to be able to show all of the props that I was talking about in front of the room, but hopefully this will help you at least get through the notes. So we're going to begin talking about sources of light. In the very beginning of your note sheet, it asks you for a definition, and that definition is luminous. And so we need to define the term luminous as something that gives off its own light. So the sun is a perfect example of something that is luminous. It has its own light source. Now, something that may be a little bit different than luminous is something that is reflective. And something that is reflective gives off light, but it's coming from another source. So the moon, okay, the moon is just an absolute perfect example of this. When you go outside at night, on the night of a full moon, and it's pitch black, but yet you can see other things around you, is because you have the moon. Now what's confusing is that that light is not actually the moon's light. That light is coming from the sun. So the sun is on the other side of the earth. I'm going to try to draw the sun. The sun is on the other side of the earth. It is shining. It is still hitting the moon, okay? But those rays are being reflected off of the moon, okay, off of the moon, and it's then shining down towards Earth. And we'll draw a little Earth right there, a little green ball. That is Earth. So obviously that is not to scale, but you get the idea. The light is coming from the moon, shining off of, or coming from the sun, shining off of the moon and on towards Earth. That's reflective. Now, talking about some of those light bulbs that we went through in our Light Lab 1, the first one that you probably know the most about is the conventional or the incandescent light bulb. You know, that's the light bulb that you see above cartoons. Okay, whenever they get an idea, the light bulb comes on. That's the light bulb that they're showing, an incandescent light bulb. The filament, which most of you guys saw in Light Lab 1, is that little piece of metal that looked like a spiral that goes down through the center of the light bulb. You can kind of see it, you know, right in here. That filament is right there, and that is actually made up of a metal that we call tungsten. Now, the reason we use tungsten is because tungsten is extremely resistant to changes in heat. Not necessarily that it's resistant to the change, but it can hold a lot of heat before it's going to melt. So any other metal that we've tried to use tends to melt when we put this much electricity through it. So using tungsten allows us to heat this filament up so much that it glows, yet doesn't change forms. It doesn't melt. Excuse me. The filament glows when electricity hits the tungsten. And what else is cool about these light bulbs is that the glass is actually enclosed so that the oxygen does not cause an explosion, because we know what happens when we mix extreme high temperatures with oxygen is that we get a boom. Okay, we get an explosion or fire. And so that does not happen, what we've done here is we have enclosed that bulb, or enclosed that filament in a bulb that has no oxygen in it, yet has this gas called argon. And the reason that argon works here is because argon is what we would call non-reactive. And since it's non-reactive, it's non-explosive. Now, you guys will learn more about argon and the reasons why it's non-reactive in chemistry, but for your case here, we're just going to go ahead and call it the fact that it is non-explosive. Now, the reason we may not like conventional light bulbs, and because we read that article in class, the reason that we're not using them as much is because they produce a lot of waste heat. Okay, and the reason that waste heat is bad is because it's still costing energy, but yet it's not going for the purpose of the light bulb. The purpose of the light bulb is to light, not to create heat, and that's what it's doing. A better alternative are the fluorescent tubes. And if you have looked up at the ceiling in Fort Couch, you notice the lights are actually fluorescent tubes. And these are really cool because all that happens here is that the electrical energy flows into the tube and it causes mercury to excite and glow. So what you have is you have this mercury on the inside of these tubes, and as it becomes excited, as that electrical energy flows into the tube, it gets the mercury atoms excited and they glow. Now, the reason we like these better is because they produce a lot less waste heat than the incandescent bulbs. So they're more electrically efficient. Okay, they are more efficient for electrical energy. There we go. Okay, yet they also produce the same amount of light. So they're giving off a lot less heat, but they're producing the same amount of light, therefore saving you energy, which is what we're looking for. Fire candles and lamps. Now you saw in our candle lab that we had a reaction between the candle and oxygen. Okay, that is where we get fire. We release light when fuel reacts to oxygen. So in our candle example, we had this wax that was simply reacting to oxygen, and what do you get? Well, you get fire and you get light. Okay, and this is produced through a chemical reaction. Same thing happens over here for the lamp, except in this case it is going to be a reaction instead of between wax like we had over here in the candle, but through oil in the lamp. Now the sun is a little bit different story. The sun is a whole bunch of nuclear reactions taking place that gives off this light. Now these nuclear reactions happen every second, and you have millions and millions and millions of them, and as they occur they end up creating little mini explosions, and those explosions give off light. Glow sticks. Glow sticks is another source of light. Now when glow sticks are a little bit different, you can actually hear when you crack a glow stick, you can actually hear the vial inside. A vial contains certain chemicals, and inside that vial, those chemicals are released into the glow stick. And when those reactants mix, those different chemicals mix, they give off light. Here, I'm actually going to break a glow stick so that you can hear it. Well, hopefully this will come up on the microphone. Okay, you can hear that cracking. That is chemoluminescence. Now my glow stick, even though you can't see it right now, is in fact glowing. The chemicals mixed, and we have chemoluminescence, so chemicals giving off light. Now lightning. Lightning is really cool, and we're not exactly sure. We do know why it is caused, but we're not sure why it behaves like this. What we have is lightning is produced when energy in the clouds discharge, and the heat from that energy makes the air glow. Now, lightning is really cool because when you have thunderstorms, you have this thing called an updraft. And as thunderstorms roll over, the updraft, or energy flow that is moving up into the thunderstorm, brings up a whole lot of other things. So it could be dust, it could be dirt, it could be whatever. And what happens to that is as it rains, you have some water forming around that dust or dirt or whatever it is that is picking up. And as it rises into the atmosphere, what happens is that it freezes. Okay, and as it freezes, it becomes ice. And the ice ends up falling back down towards Earth. And that's falling as hail. But also what's happening is that hail falls down towards Earth is that it happens to be hitting other ice that is coming up while the other ones are coming down. So they're rubbing up against each other, creating a lot of friction, creating a lot of static electricity. And as that electricity builds, eventually the atmosphere can't hold that electricity anymore, and it's discharged as lightning. Very cool to see. There is actually a video on blended schools. I'll go to my blended schools page real quick so you can see that. There's a video right here that's really cool that explains all of that stuff on lightning. Okay, light-emitting diodes, or as we know them, LEDs, they produce light directly from the current. And because they run so cool, they are even more efficient than conventional or incandescent or fluorescent light bulbs. So they don't have a filament, okay, and they don't have an electrical current that has to run through the tube to excite mercury atoms. All it is, it's the actual current that is producing light here. Runs very cool, and it's very efficient, and is really what we as a society are moving towards in terms of light bulbs. Okay, you're going to start to see, you should already see a lot of these, and you're going to start to see even more. Lasers. Now this is everybody's favorite part. Lasers are extremely cool because they're bright. We like to control them with computers and change when they flash and where they flash. But it's really cool to understand how they work as well. And so it's kind of similar to the fluorescent tube, where it is a flash of light that is controlling, that is exciting different atoms in a special tubes. Now these atoms, it depends on the atom for whatever color light that you get. Okay, so if you are wanting to see blue, then you need a specific type of atom. If you want to see green, you need a specific type of atom. And scientists have begun to change those different atoms and mix those different atoms to get different colors. But it's an extremely intense beam of colored light. And again, if you go on to blended schools, you can watch a laser show. Now, it's a little bit lengthy of a video, 10 minutes long, but some of the scenes in there are really cool with the music and the lights. Okay, the last slide we got here is about organisms and the fact that some organisms can produce their own light. Now, you are incapable of doing this. You are incapable of producing your own light, but there are some organisms out there that actually can. We call this bioluminescence. Okay, bioluminescence, or life that literally makes its own light. So bio is life, luminescence is light. So light. And you can see this in flashlight fish or fireflies, a whole bunch of small organisms or microbes, okay, bacteria. They can also produce their own light. And once again, there is another really cool video on Blended Schools that I want you to watch that is called Bioluminescence on Camera. It's about a whole bunch of scientists that actually go out and look at these fish that are producing light. Okay, so hopefully this helps for those of you who weren't here or who missed class one day or just want to go back and watch it. Let me know if you have any questions.